Hey folks, this is Phil from Gizmo Data. I want to show you something cool we've been working on with GizmoEdge. Specifically, we're going to dive in with a 10 terabyte TPC-H data set and churn through it like butter. So I'm really excited about this because Microsoft has granted me some cloud credits to demonstrate the power of distributed processing with GizmoEdge. So I'm very thankful for that. So thank you, Microsoft and Azure, for giving us the credit. All right, so we're going to jump in here, go to gizmodata.com, scroll down, and you go to our product section, and you go to the GizmoEdge screen here. And we're going to go ahead and try GizmoEdge. But before I do that, when you go to this page, just read through it, and you can see all the cool features that GizmoEdge offers. But basically, GizmoEdge is a distributed SQL engine that can leverage IoT, Internet of Things devices, but also can use cloud compute, which I'm going to demonstrate today with Kubernetes. We can use Kubernetes compute and divide and conquer huge data sets. So the TPC-H 10 terabyte data set I'm going to demonstrate today is 10,000 gigabytes. That's a lot of data. So we're going to see how fast we can process that data and aggregate it and so forth. All right, so we click on the Try GizmoEdge button. It takes us here to the GizmoEdge IDE. We're going to go ahead and go to dark mode because, again, all the cool kids do it. And before I run any queries like the TPC-H test battery here, let's just get a record count. So we'll select count star from line item and run this guy. And you can see here that we've got quite a few records. So if I select that here and I show you, we have 59 billion, 0.9, almost 60 billion records with a B. So that's a lot of data that we just churned through there. And you can see that query took about less than 1 second to execute. Now, you can see here the device distribution, what we ran on. So we're running in Azure Cloud, and we're using standard E64 PDS v6 machines. It looks like we're using 1,000 of those. We're actually not using 1,000. We're using, I think, around 65 or 66. Each worker that I've got running on this machine has about 4 CPUs. So we're fitting about 15 workers per machine. So we are using a lot of compute. We're actually using 4,000 CPUs when we run this. Each worker is running DuckDB, and each worker has about a 10 gigabyte chunk of the data. So 1,000 times 10 is 10,000 gigs, and that's 10 terabytes. All right, so, and you can see the little icon here that says, hey, we're running a Kubernetes. All 1,000 workers succeeded running their respective chunk of the data. All right, so let's go ahead and run some interesting queries here. We'll go to the shipping priority query. It's got an order key, an order date, ship priority, and we're going to sum the revenue here. And we'll just run this. Now, bear in mind, there's no caching going on here other than OS caching or any caching that DuckDB offers for caching the data that is going to be read. But that being said, we're not caching any results whatsoever. So let's go ahead and run this and pray and hope that it all works. All right, and you can see how fast that all 1,000 workers processed their respective chunks. That took about 1.6 seconds. And we got an answer back here, and you can go through the result set here. So this returned 10 rows because there's a limit of 10, but it ordered by revenue descending and order date. And it applied those where clauses. We can get less restrictive. We can change these where clauses. This actually isn't a good query with that, but we'll try to find another one. So let's do query 4 here. We're going to group by order priority, get a record count. And we're filtering on some date range here, doing an exist query. That's relatively complicated here. Let's go ahead and run this. All right, so that ran 1.4 seconds and went through all those 60 billion rows of the fact data, and it aggregated here. Now, you see the row count here, or the order count and the grouping set, that's only 100 million or so. But we can get less restrictive, right? So we can, let's get rid of that date range altogether, and let's run this. All right, so we still processed all of the data without hardly any filter. And you can see each one of these rows represents 2.7 billion rows, roughly, that got grouped and aggregated in there. So a huge amount of processing that went on there. All right, so let's try to run query 5. Boom, we just churn right through that data with ease. All right, and then let's go ahead and run query 21. This is pretty complicated query. Got an exist correlated query here, some joins, some aggregation that's going on. It looks like we're grouping by suppliers. So we distributed that out and all 1,000 workers responded, and that took about 4.3 seconds. Now, if you were to run these queries on an individual machine with 10 terabytes, be prepared to wait. It's going to take a long time to run. For example, DuckDB on a 64 CPU node running query 1 on 10 terabytes, even with local NVMe, can take 100, 200 seconds to execute. So being able to divide and conquer this big data set is essential. Right, so I just want to demonstrate that. Like, again, we'll run query 1, and we got a ship date restriction here. We're only querying one table, but we're going to churn through all of it. And boom, we run that in about 2.16 seconds. And all 1,000 workers succeeded, and you can see your result set here. And we can take off that where clause. Let's just run it all. Boom. We went through all that data, all 60 billion records, aggregated it all to these 4 rows. And you can see how many rows went into each of these aggregates. And you can see this one here aggregated quite a bit of data. Let's see there. So 14 billion records went into that one row, that aggregated to that one row. So you can see we can churn through tremendous amounts of data pretty rapidly. Now we're being aggressive here. We're using a lot of compute. I'm using 4,000 CPUs. So if we go and we can look here at our Kubernetes cluster, I got an alias called KP for kubectl get pods. And you can see I got quite a bit of workers running here. And you can see, like if we go to the logs for those workers, you can see that they've been pretty busy. So if we tail the worker here and we run a query, you can kind of see what happens in real time and see the latency. So I'm going to get run here, and we should see some activity down here in the bottom. And sure enough, you see that got distributed. It ran the query. So it received the message at 38 seconds after the minute. It executed the query, succeeded, produced 4 rows at 39 seconds. So it took 1 second to execute. And it said, hey, by the way, you're the fastest worker for this query for this shard. So because only one worker has this shard. So it lets you know, hey, you're the fastest guy for this shard of data. So this is something that I'm really excited about, this engine. So if you have any questions or you'd like a demonstration of this with your data, please contact us at info@gizmodata.com or visit our website for more details on this product. We'd be really excited to talk to you about it and do a proof of concept with you to see if it would work for your workload and your data. So I'm going to run query 19 here just because this is fun and really cool. And you can see it ran very, very rapidly. So again, went through the 60 billion rows, 10,000 gigabytes of data, a tremendous amount of real-time processing. We're not caching any results. Just really fun project here that we're working on. And we can change this too. We can change these queries. We can get rid of a group by field. Let's get rid of that. And you see, again, we're not caching any results. And you can see that we've just grouped by the return flag. And so only produced 3 rows this time. And we've got a tremendous amount of data that went into each of these aggregates. So really excited about this. This is really fun for me. So it's been a passion project for a long time for me. I'm really passionate about taking huge data sets and processing them very, very rapidly with very low latency and really great performance. Please let us know if you're interested in seeing more info on this. I'll be glad to do a demo, private demo, and go as in-depth as you'd like. So I'm just really excited. Thank you very much and have a great day.